State functions, okay? The word state function refers to a property of a system. So it's a well-defined value for a given equilibrium state. So examples of state functions would be temperature. Okay. If it's systems at equilibrium, its temperature is well defined. So temperature is an example of a state function. Pressure, volume, okay. Things you can use to describe a system at equilibrium are called state functions. Okay? They do not depend on the history of the system. In other words, it doesn't matter how you got to that point. It doesn't matter how the system got to that particular state. These state functions are well defined. So if you ever go, if you a system ever undergoes a series of changes and it goes back to that particular state, those values would still be the same. Otherwise, it would be a different state. So state functions we say are not path dependent. Okay, it doesn't depend on how you got there. They're path independent. Path functions, okay, are quantities that depend on how you got to your final state, your current equilibrium state. So this would be the opposite of a state function. So examples of path functions are work and heat. Okay, path functions depend on how you get there. So if you reach a particular state and it requires heat or work to get there, it depends on what you actually did to get to that particular state.